The next thing that we're going to be working on, we just finished up with some quadratics, is we're going to get into a family called polynomials. So if at this time you want to, maybe hit pause on your video and then start copying this down because these are some super important notes that you're going to have to take. So a polynomial in x is a function that can be written in the form, and this looks super creepy, doesn't it? Where you're like a sub n, x sub n plus a sub n minus 1, x sub n minus 1, a sub n minus 2, but like all this crazy stuff, it just goes on. But here's a couple of things to help you better understand and define what it means. So one of the first things is that the power for all of your x's has to be 0 or any other positive whole number. So for example, you could say like 2x squared would be a polynomial. 5x to the fourth minus 6x plus 3 would be considered a polynomial. And the reason why it's called a polynomial is because your degree here is 2. This here is also a polynomial because your degree here is 4, this degree is 1, and this is technically x to the 0 power. So when we talk about polynomials, these are examples down below here, which also represent really nice examples of polynomials, because this is technically 4x to the 0, this is x to the first, this is 2x squared minus 6x minus 3, and this little a sub n here just kind of represents the coefficient that we're talking about. So if, for example, the only part of my polynomial was like an x squared, so in other words, my a sub 2 in this guy right here would be a 2, my a sub 1 would be that negative 6, and then my a sub 0 would be the constant function, which is negative 3. So if I were to use that, then my a sub 2 would be equal to 2. That's a 2 there, by the way. My a sub 1 would be equal to negative 6, and my a sub 0 would be equal to negative 3. If all of a sudden I did this guy over here, if I looked at this guy, which is called, by the way, a third degree polynomial. This is called a second degree polynomial. This is called a first degree polynomial. This is called a 0 degree polynomial, because polynomials are based on the highest degree that they have. So if you look at this one, what would be the degree of that polynomial? And again, it's the highest exponent. So if you said 8, bravo. If you looked at this function, what would be the highest degree of this polynomial? You're correct if you said 5. So going back over to this guy to better understand the weirdness of this, because polynomials, you can have it where it's x to the 100th, x to a billionth, x to a trillionth, x to, the 12th, anything. But it's just knowing and understanding that the a sub n, the guys in front of it, are always going to be the coefficients. So in this guy, because it's a cubic function, over here on this one that I have circled, a sub 3 is equal to 4, a sub 2 is equal to negative 8, a sub 1 is equal to negative 7, and that a sub 0 is equal to 1. If I go over here to this guy, on the other hand, I now have a sub 5 is equal to negative 2. There's no, because it should go down in descending order, so I should have an x to the fourth and x cubed and so forth. But a sub 4, there's nothing there, so the coefficient is 0. A sub 3 is also 0. But a sub 2 is equal to 1. And noticing that there's an a sub 1, which should have the x sub 1, is 0 also. But then a sub 0 is equal to 7. So it's just getting into the habit of not being afraid of what a polynomial looks like. The most important is to know that all of the powers have to be 0 or any other whole number, positive whole number. So in other words, it can never be x to the negative 1 power because it's not a positive whole number. So that's what makes polynomials really special, is that if somebody said x to the negative 8th, you're going to say to them, that's not going to be a polynomial, then it doesn't fall under that family that you would have there. Okay? So if you want to take a moment, drink that in, and write all that down, do that, and then we'll hit the next page. So as I said to you guys earlier, the degree of any polynomial is the highest exponent. And note that a polynomial is x to a power, where the power is a whole positive number. So starting with the smallest degree polynomial, we talk about a 0 degree polynomial, it would be what kind of a function? It would be like where it's just a number, like y equals 5, y equals negative 1, I could even call f of x equals 3. This is called a constant function. And the reason why it's called a constant function is because if you go back, right over here, all the numbers by themselves, all of these numbers all by themselves are called the constants. So hence it's called a constant function. And if you wanted to graph a constant function, y equals 5, y equals -1, f of x equals 3, I hope you're all telling yourselves that these are going to look like horizontal lines. Okay? Moving on to a first-degree polynomial. A first-degree polynomial is a linear function. And an example of a linear function, because it would be y is equal to 2x plus 1, because it's x to the first power, y equals -1/3 x. G of, my pen is acting weird. Here we go. Stop. G of x is equal to 2/5 x minus 3. Those are all linear functions. If I were to ask you guys what a second-degree polynomial would be, it's when your highest degree is 2. And I hope you are all saying that gives you a quadratic. Okay? Quadratic. If you guys want to pause this and go fill it in yourselves and come up with examples, that would be delightful. So if this is quadratic, you can go like f of x is equal to 3x squared. Y is equal to 1 minus 2x squared, and so forth. I'm not going to get crazy here. Do you know what a third-degree polynomial is called? You guessed. It is a cubic function. Very good. So you could have y equals x cubed. You could have f of x is equal to x cubed minus 8x squared plus 2x minus 1. You could have g of x is equal to x cubed plus x minus 3. Anything you want, just so long as the highest degree is, you got it, is 3. If you march on to a fourth-degree polynomial, do you guys remember what that's called? If you said quartic, bravo, that would be a quartic function, and you could say y is equal to x to the fourth. You could say g of x is equal to -2x to the fourth plus 1/2 x cubed minus 3x plus 5. Just so long as, no matter what those terms are, the highest term has a degree of 4. And then we're going to finish off with a fifth degree because we only have so much space. Do you want to take a guess as to what that is? I'm going to write it in as you think about it, or you could have paused it yourselves for those of you who actually show a little interest. So you can do x to the 5. G of x is equal to -2x to the 5th, or make it 2/3 x to the 5th minus 6x to the 4th plus 5x cubed minus 1. Anything like that. So these are kinds of functions that we're actually getting our hands wet and enjoying, okay? And I would like to go back for just a moment, and I want to say that these polynomials, like when you see a polynomial in this form, I hope, like, going to this, can you identify what kind of form it is? Like if you had this is what form of a quadratic? And this would be a form of a certain form of a cubic. This would be a certain form of a quintic. This is an 8th degree, so I could just basically say that that's an 8th degree, right? 8th degree polynomial. But the most important thing is you should note that these are all in standard form, because just like quadratics, and quadratics, if you notice, fall into a family of polynomials. So in other words, quadratics are cute, but there's a big family that he's a part of. So we just want to talk about that. If we can put a polynomial in standard form, if we can put a quadratic in standard form, we could also put it in factored form, which means we can put all of their other friends in factored form as well. Which brings me to this. So polynomials can be put in factored form, where you have y equals, that looks familiar, the a times the x minus c, x minus d, x minus e, x minus f, where c, d, e, and f are considered the zeros. And I want to put this off to the side, and we say that the factors are x minus c, x minus d, x minus e, and x minus f. So the zeros are the actual c, d, e, and f, but the factors are x minus c, x minus d, x minus e, x minus f. And note that the a is how wide or skinny that a polynomial is. So what we're going to do now is we're going to jump over to Desmos. Okay, we're going to jump over to Desmos, and I want to type in something in factored form for you to help you understand how cool things are. So if we start off with like y is equal to x to the 3rd power, I hope you all remember that it looks like that cool, funky curve, that curvaceous thing that looks like a tangent. It's not a tangent. Let's not say it's a tangent because it's not. It's a cubic function. So it's going to have this nice little curvaceous thing that's going on to it, okay? But if I, on the other hand, go ahead and, type in something like y equals, let's say x minus 1 times x minus, let's make that x minus 4 times x plus 5, okay? So you just saw something interesting happen, didn't you, right? You just saw something interesting happen, and I am going to go ahead and make this 106, and I'm going to make this 106 so you can get a feel. I don't like that, that's too big. 106 like this. So if you look at that, what I want to show you that's super interesting, okay? So we have f of x is equal to x cubed, which is this guy right here, right? So this is our basic x cubed. And you'll notice that we only have 1 0 for f of x is equal to x cubed. On the other hand, when I put this in here, and by the way, if you multiply x minus 1 times x minus 4 times x plus 5, x times x times x is going to be x cubed. So this right here is going to be a cubic function. But what is interesting is that there is a 0 here. There's a 0. Whoops, no, not there. There is a 0. Whoops, I'm going to do something here. I'm going to type in the point 1 comma 0. Whoops, 1 comma, come on, 1 comma 0 and hit label, okay? I'm going to put this guy in here, which is 5 comma 0, and then this guy right over here, which is 4 comma 0. So what I want to show you is that when these are in factored form, we already said that these represent the zeros of a function. So I find it super interesting that when you have a cubic function, right, you can have a maximum of 1, 2, 3 zeros, okay? We can also have a minimum of 1 0, and then I want to show you something interesting. I'm going to turn this off, and I'm going to turn this off, and I want to show you something here that's super interesting. Y equals x minus 1, let's go, whoops, no, x minus 1, I'm not a good typist as you guys could see, and then, whoops, to the second power times x, let's say, plus 4, okay? Now, what I want you to notice here is how many zeros are there. How many zeros do you see here? There's 1 here, and again, there's 1 there, which is super interesting. So when you look at a cubic function, you can have, I'm going to turn him back on again, you could have 1 0, you could have 3 zeros, 2, 2, 3 zeros, or you could have 2 zeros, which I find super interesting, okay? I'm going to turn that off. I'm going to turn that off for a second too, because I kind of want to focus on this for a minute, okay? Actually, no, I don't. I want to turn, whoop, did I get rid of y equals x cubed? I didn't mean to do that. Okay, y equals x to the 3rd power. So when you look at this, it's almost as if take your hand, and if you remember, this point right here at the origin is called a point of inflection. So it's almost as if you grab it with your hand and you pull it up, and when you pull it up, you stretch it so that you get an actual minimum, and you get I'm going to say relative, that you get a relative minimum and a relative maximum, which I find super interesting, okay? Another one that I'm going to show you guys is, let's get this out of here, get out of here, get out of here. I'm going to go to a quartic function, and if you do y equals x to the 4th power, if you did y equals x squared, it would be a parabola, right? So if I did y equals x squared, you would have this parabola. It's super wide. But then if I did y equals x to the 4th power, and if you were to do a table of values, you'll notice that it's a much skinnier parabola. And it makes sense because if I raise anything to the 4th power, it's always going to be positive. So if I put -1 and +1, they're going to have the same y value. If I plug in -2 and +2, they're going to have the same y value. So when I have x to the 4th like that, it's going to look something along the lines of this. But what I'd also like to show you is if I give you a quartic in factored form, right? It would be x minus 1. We'll do, no, I'm going to do x minus 3 times, say, x minus 6 times x plus 3 times x minus, I'm sorry, let's do x plus 7. Let's get crazy, okay? So what I want to show you, I'm going to turn this guy off and I'm going to turn that guy off. So what I'm going to show, no, I'm going to turn you back on actually. What I'm going to do is I'm going to show you again, if I go ahead and move out, you can go ahead and look at this, and this looks like the letter W. And because it's an x to the 4th power, x times x times x times x will raise it to the 4th power. So what I find interesting is you have a 0 here, a 0 here, a 0 here, and a 0 here. So now it's almost as if you grabbed the vertex right here and you pulled it straight up, and again you made this look like this shape of a W. Made it look like this shape of a W. So when you want, what you're going to do is you're going to start exploring on Desmos. And what I'm going to do is I'm going to get you started because there is a Desmos activity that you guys are going to do. So this is one of the Desmos activities that you guys are going to have moving forward as we go along. So for this one here, you're asked to match the graph parabola by writing its equation below in factored form. So I'm looking over here and I'm like, okay, if my 0 is -6, then my factor is going to be x plus 6. If my 0 is 2, then my factor is going to be x minus 2. So I'm going to type in y equals x minus 6 times, I'm sorry, x plus 6, right? You guys should be like, oh, it's plus 6, Ishwa, and then times x minus 2. And sure enough, I've got myself my parabola, blah, blah, blah. If they gave me other points on a graph, I'd have to use it to find a, which I know is going to be coming. Now, right over here, if you look at this, you notice that we only have 1, 0, right? So if we only have 1, 0, we have x minus 4. If I just write this as x minus 4, the problem is that it's going to show up as a line, which you can obviously see here, but I don't want it to show up as a line. I want it to look like a quadratic. So this is almost as if it's touching the x-axis. So what I'm going to do is I'm going to square it. And if you square it, that's called a double root. So it's a double root when you actually have something like this because it's actually parabolic in shape. So to make it happen, you're going to want to go ahead and say, I want to do that twice. So when you see something tangent to the x-axis where it gives it a kiss and then it bounces back up again, it's going to be something squared. Okay, so you're looking at this. The one shown in red has been shifted to create the blue graph. So this was, if you go back, and the reason why, if you go back, this was y equals x squared. X squared, so at 0, it's 0 squared. So it's almost like this is x minus 0 quantity squared. So we shifted this to the right 6 units. So if you guys want to pause and try this on your own, that would be great. But you should be writing this as y equals x minus 6, whoops, to the second power. Okay? Does it not like my response? Is there a way to write this as a power? Is that what it is, a keyboard or something? I'm just going to go to the second power and call it a day. And hit submit, and then go next. Now, over here, your original graph is in red, and you want that guy to be in blue. So you have to figure out how to move A. And if you notice, if I make A less than 1, it gets so fat and wide. But the closer I merge it, the more skinny it's going to be. So you can see that 3.5 is the value of my A, and you'll notice that my zeros are -4 and +9, okay? So moving along, over here, if you notice this guy here is in blue, so I'm going to have to flip it. Oh, I see, it's backwards. So you can tell that A is going to be negative, and we should have known that as it was going down. And go ahead and you can just see how the A is a factor in all of these. So it's saying if the graph in red is y equals blah, 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 and shown in blue is blah, blah, then explain what you know about the value of A. And the graph is shown in blue. We know that A, first of all, if you look at it, the parabola is upside down. So we would say that A is negative and less than 1. Because A here is 1, and you see how this is skinny, and then this guy's wider. That means that and A is negative and less than 1. So we're going to hit next. Okay, so now here's where we're getting into some polynomials. So right here, if you notice, we have 3 different zeros. So for you guys, you're going to want to say, okay, my first 0 here is -8, 0. My second one is -1, 0. My third one is 5, 0, right? So that means then, I don't know why I had to kick off of there, but we have y is equal to, we have, if it's -8 is a 0, that means it's going to be +8 is going to be a factor, right? And then my next 0 is x minus 1, and you'll notice it's parabolic, but then if I do x minus 5, right, I have this. So right now, it's telling me that the problem is what I have is that it's not exactly matching what that guy is over there. So what I'm going to do is I'm going to grab the point -3 comma 80, okay? And what we're going to do is, let me see, I'm going to write this down. We have x plus 8, x minus 1, x minus 5, and we're going to use -3 comma 80 to find out what a is equal to. So we're going to march on over into, let me go over here to workspace. So in workspace, we're just going to march on to the next one. So I know that we have that y is equal to a times x plus 8 times x plus 1, times x minus 5. And we're going to plug in the point -3 comma 80 in for x and y, and then we're going to solve for a. So we have 80, right? I put 80 in there. 80 is equal to a times -3 plus 8 times -3 plus 1 times -3 minus 5. So 80 is equal to a times, now this is all a product here. So this is a times, this is 11 times -2 times -8. I'm so lazy, so forgive me. So we have, why am I so lazy? So we have 11 times -2 times -8, okay? And that's going to be 176. So 80 is equal to 176a. And then divide both sides. So 80 divided by 176 is math frac. It's going to be 5 over 11. So 80 over 176 is equal to 5 over 11, and that is equal to a. So if we go back into Desmos, we're going to go ahead and we're going to put 5 divided by 11. What happened here? Wait a minute. Am I trying to match mine with, I thought, did I pick the wrong point? And so let me go back here. If I go back here, what happened? Wait a second. Oh, this was x. Oh, Charlene Krista, plus 1. Oh, here we go. Okay. Well, that just changed. That shouldn't have changed everything, right? Yes, it did. Okay. So, oh, you know what? I totally screwed up. This is why Desmos is kookadoodle. So the red graph is my graph, right? And so if I get this out of here. All right, hold on. Let me get this out of here. I love how this is happening. This is good. I guess A was 1. That's stupid. Really vey. All right. Anyhow, let's go on to the next one. So we have this guy, -7 and +2. But you notice that it's dipping down and going back up again, right? So I'm just going to plot that point too because that's really aggravating me. This is a super, ooper, duper special point right here. So this is called a what again? I hope you guys said double root. So when I write this, I'm going to write y is equal to x plus 7 times x minus 2. And then if I go squared, sure enough, it's all good. And if you notice, by the way, we could actually prove that a is equal to 1. Because what I'm going to do is I'm going to go back over here, and if it doesn't, I'm going to be like, Desmos, you're a hot mess. I'm going to use go to a new page. Right, go to a new page, and we have that y is equal to a times x plus 7 squared times, no, not that one's not squared, times x minus 2 squared, and I saw -2 comma 80 on that graph. So if I plug in 80 for y, a times -2 plus 7 times -2 minus 2 squared, I better get 1, by the way, and if I don't, I'm going to be super angry. So it's going to be a times, so this is 5 times -4 squared. So this is going to be 16. Oh, lucky you. So 80 is equal to a times 5 times 16, and 16 times 5 is in fact 80, so it's their lucky day. So 80 is equal to 80a. So a is equal to 1. I think it's important to verify, and I don't like that, they're not asking you to verify. I'm going to ask you to verify, okay? So again, you can go ahead and make these, switch these. You can actually see that you have to make a smaller because when you originally had it, you were up here. So now it's your job. They're like, okay, it's time to find a. So I'm going to leave you guys with this here. This was actually a half, I believe is what it was, right? A half worked. I'm going to leave you guys here and just say that it's going to be your turn to finish this challenge. I went through the first 9, but I'm just curious as to what you find out about double roots and what you find about triple roots, because there's something called triple roots, and I want you to think about what that means too. And before I go, I do want to point out that, if you have something like y is equal to, let's say, x plus 1 squared times x minus 3, right? This right here, if this is x squared and there's another x, this should tell you that this is a third degree poly, okay? If, for example, you have y is equal to x minus 4 cubed times x plus 1, right? This is x cubed and another x gives you x to the fourth, so this should be a fourth degree poly, okay? Now, if you go ahead and you look at this one right here, this one here is called a double root. And this guy right here is called a triple root, okay? Your job is to find out exactly what they are and what they mean, and Desmos will help you do that, okay? So that's it. So hold on a second. This is a double root. This is a triple root. This is just a linear. It's just a linear. And I want you to basically be able to tell me in a graph, so what do those things graphically mean? So as part of your investigation is I want to know, what does this graphically mean? And I look forward to hearing what you guys have to say about that.